All right, what's up, everybody? Moving on, lesson 3.6, which is going to be chapter 3 review. Can you believe it? We're already going to be finishing up chapter 3. Again, just like always, this isn't really going to be a lesson where we learn anything new. We're just going to be going through a bunch of example problems that are similar to what you will see on the test. Okay. All right, so notice you have a word bank for this geometry proof, right? You have all your statements. You need to put them in the correct order. You have all of your reasons. You need to put them in the correct order. Okay, remember, always start with your automatic answers. Rewrite what is given to you in the first statement. Okay, so I am going to abbreviate, write a little bit shorter. I'm not going to write out the entire thing, but angle A is congruent to angle, or sorry, equal, not congruent. Angle A equals angle B. What else does it say? It also says that angle B is equal to angle C, right? And we know, so we used that already. That's an automatic gimme answer. We know that given is always the first reason. That's also an automatic gimme answer. And then we know that we have to always rewrite what we're trying to prove as our last statement. Angle A is equal. Oh, sorry, I messed that up. Angle A is equal to angle C. So that means we know that one is wrong, out, right? Okay, and now we only have one statement left for us, so we can conclude that angle A is congruent. I am so sorry. These, ladies and gentlemen, should be switched. This is a poor quality image. All right, we are actually trying to prove that angle A is congruent to angle C. All right, poor quality image, that should be congruent. So the congruent should be down here. The equals should be up here. I'm going to actually erase those and rewrite them because I've messed up. We're off to a great start. Killing it here in lesson 3.6. Okay, so this one should be this. We're rewriting our proof is an automatic answer. Angle A is congruent to angle C, which means that the only answer that we have left is angle A is equal to angle C. Beautiful. Okay, now we need to figure out where is transitive substitution going to go and where is definition of congruent angles. Well, if A is equal to B and B is equal to C, we can confirm that A is equal to C. That there is due to the transitive or substitution property. And again, definition of congruent angles always, whenever we change from an equal sign to a congruent sign or the opposite, that is always going to be the definition of congruent. Cool. Not a great start, but we fixed ourselves. Always fix your mistakes. We're going to crush it for the rest of the way. I believe in us. Sketch the fourth figure in the pattern below. This is inductive reasoning, looking at patterns, being able to make a conjecture based off of a pattern, right? Notice each square got cut in half, and then that half got cut horizontally, and now this half is going to get cut here, so it should be just a smaller sliver of what is shaded. Write the next three numbers in the pattern. How are we changing? 0, 1, 3, 6. 0, 1, 3, 6. Well, that is adding 1. That is adding 2. That is adding 3, which means we're probably going to add 4, which would give us 10. Then we're going to add 5, which would give us 15. And then we're going to add 6, which would give us 21. That is the pattern there. Okay, identify the hypothesis of the statement. If x plus 4 equals 5, then x equals 1. Remember, conditional statements. If P, then Q, right? Conditional statements. If P, then Q. So this here is going to be your hypothesis. X plus 4 equals 5 is the hypothesis. Identify the converse of the statement. Remember, converse is just switching a conditional. So if cats fly, then ducks bark. Obviously, these are two false things, but in a way, it then makes it true, because if cats fly, then ducks will bark, because cats don't fly, therefore ducks won't bark. So it's kind of weird that those are two false things, but in a way that makes it true. Anyways, converse, just switch them around. All right, this would be if ducks bark, then cats fly. That should be a lowercase t. I apologize to all you English teachers out there. Show the conjecture is false by finding a counterexample. All angles are right angles. Well, and a counterexample would be obtuse angles or acute angles. Okay, that's not true, right? There's more than just right angles. All triangles are equilateral. Technically, we haven't done our unit on triangles, but I'm sure that you should have learned about triangles a little bit in middle school. We have isosceles triangles. We have scalene triangles as well. So not all triangles are equilateral. Okay, write the if then form, the converse, and the, okay, so ignore this other part. Okay, this should say just the conditional, converse, and biconditional of this statement. Okay, I included a text box here so that way I can write it. Okay, so a poet is a writer. If we wanted to label it, right, circle your hypothesis. Poet will be Q, writer will be our conclusion, which will be, poet will be P, writer will be Q. Poet, hypothesis P, writer, conclusion Q. Okay, biconditional statement would be if it is a poet, then it is a writer. Okay, if P, then Q. For converse, now we just switch them. If someone is a writer, then they are a poet. Now think about the truthness of these two sentences, right? The first sentence I would say is true. If you're a poet, it could be argued that you're a writer. However, the second one I would say is not true. If someone is a writer, then they are a poet. Not necessarily. You could be a writer of short stories. You could be a children's writer. Okay, so the second one is false. So technically, we shouldn't be allowed to write a biconditional statement, but it's okay. Let's just go ahead and do it for practice sakes. So remember, biconditional does not start with the word if. It's just P, if and only if, Q. Okay, so we could say someone is a poet if and only if they are a writer. Boom. Beautiful. Let's go back. Okay, algebra proof. If we are given this, prove this. Remember, get that easy money. Always rewrite your original statement. 6 parentheses x plus 4 equals 60. Our first reason is always the word given, forever and ever. And we always rewrite what we're trying to prove, x equals 6. Okay, I always like to write my work off to the side to keep my proof chart nice and neat. Okay, so what do we do here with the parentheses? We have to multiply across. We need to distribute. So 6 times x gives us 6x. 6 times 4 gives us plus 24 equals 60. What did we do? What is our reason? We used the distributive property. Okay, next, if we have 6x plus 24, 6x plus 24. Again, I'm going to write it off to the side so that way I keep it nice and neat. We got to get rid of plus 24. We're going to subtract 24 from both sides. Those will cancel. We end up with 6x equals 60. That's a 60. 60 minus 24 ends up with what? 36. All right, so 6x equals 36. All right, what did we do? What did we do to get rid of the 24? We subtracted, so that's SPOE. SPOE, we subtracted. Okay, now we have 6x equals 36. To get rid of 6, we divide. All right, got it. We already wrote this here because it's telling us what we're supposed to prove, but let's double check. Is 36 divided by 6? That does, in fact, give us 6. We are correct. How did we do it? What did we do? We divided. That is the division property of equality there. Name the property that justifies the statement. If 3x equals 6, then x is equal to 2. What did we do? How could we get rid of this 3, right? We should divide both sides by 3, so that is the division property of equality. Name the property that justifies this statement. If x equals 2 and x plus y equals 3, then 2 plus y equals 3, right? Well, they told us that x equals 2, so we just took the 2 and we substituted. Substitution property, ladies and gentlemen, plugging in the 2 to give us 2 plus y equals 3. Okay, complete the proof. This is a really big geometry proof, okay? It's all right. Take it piece by piece, little by little. We can figure this out. Okay, I've given you a word bank to work from. Okay, notice the first one. What is always our first state or our first reason? It is always going to be the word given, right? Cancel that out. But notice it says AC equals 13 and BC equals 3. That technically isn't in our given statement here up at the top. However, it is given to you over here in the picture. AC, the entire segment, is 13. BC, the small segment, is 3. So it is given to you, even though it wasn't written out, it was still given to you in the picture. Okay, next, AC equals AB plus BC. So AC, the entire segment, is made up of this AB plus BC. Well, we are adding segments here, ladies and gentlemen. So that one is going to be segment addition. Eliminate that. Okay, 13 equals AB plus 3. Okay, well, we said that AC was equal to 13, and we had AC. All we did was replace AC with 13. All we did was replace BC was 3. So that there is the substitution property. Substitution / transitive property. Okay, and if we have 13 equals AB plus 3, right, we subtract 3 from both sides to get AB is equal to 10. That there is SPOE. Okay, now AB is congruent to FG. That's given to us. AC is congruent to EG. That's given to us. That is our other given piece of information. Okay, AB equals FG and AC equals EG. Notice we went from congruence to equal, that there is going, oh, sorry, I'm not eliminating these. We used SPOE, we used one substitution, and we used given again. Sorry about that, right? But anyways, back to this, we changed from congruent to equal. Whenever you change from congruent to equal, that is the definition of congruence, which is this one here, definition of congruence, get rid of that. Okay, now FG equals 10 and EG equals 13. Okay, again, if we are saying that these two are equal to each other and we found that AB equals 10 and AB also equals FG, now we are, that there's the transitive property. Okay, we can say that it's substitution or transitive. That one's more, I would lean towards transitive, but they are interchangeable. Okay, there. EG equals EF plus FG. So EG, the entire big segment, is made up of EF plus FG. So that we are adding segments, which means it's segment addition property. We cancel that out. Now, since we said that EG equals 13, we're replacing. Since we said that FG equals 10, we're replacing. So that there is also substitution or transitive property. We've used that, which leads us with only one more. But again, we can also tell if we have an equation to get rid of 10, we subtract 10 from both sides. That is SPOE. Okay, so this may have seemed like a really big, hard problem. Okay, it really wasn't too bad. Just use process of elimination. Look at your statements to help give you answers and work through it. Okay. Name the property that justifies the statement. If PS is congruent to segment WX, then we can conclude that PS is equal. Notice we have changed from congruent to equals. Whenever we change from congruent to equals, that's the definition of congruency. I want to say that might be it. It is. Please study. Make sure you're working hard, preparing yourself for that Chapter 3 test. I'll see you in class. Have a great day. Go Mustang.